Hello and welcome. Today we're going to be talking about Ubuntu on Amazon Web Services. We'll be reviewing some of the ways you can use Ubuntu on AWS and some of the service integrations. I'm going to keep this as focused as I can on builders. This is not about making a business case for moving to a cloud provider, and we're not going to be discussing pricing of any of the services I talk about here. You can find all that on the website. By way of introduction, my name is Mark Thomas, and I'm coming to you from the United States in the Sonoran Desert state of Arizona. I'm a solution architect with the AWS Partner Organization, and I have the privilege of working with Canonical as an AWS partner. I'm also a longtime Ubuntu user and an Ubuntu member. I did my first install of Dapper Drake, and my first production server deployment was on Lucid. I regret that I'm not able to be there in person today. I had planned on being there and delivering this in person, but there were some technical difficulties with my travel. It's a privilege to be able to present here today, and so this was the best option that we had available. I do appreciate your being here today. I know you have a lot of presentation options that are available to you. So let's get started. So the most obvious place for us to start today is in compute. We'll start with Amazon Elastic Compute Cloud, or EC2. This is where you launch your Ubuntu virtual servers. It's pretty commonplace. The Ubuntu images that you launch in EC2 are the official supported Ubuntu images, and they're available for all modern instance types, both x86 and ARM, what we call Graviton. You can go to the EC2 console, pick your Ubuntu release from the EC2 Quick Start and launch your instance. If the release you want isn't there, you can find it in the AWS Marketplace. You can also find daily builds for all of the LTS and interim releases there. You can find the current image of Ubuntu using the Ubuntu EC2 image finder on the ubuntu.com website. And you can also find it by querying the public parameters in Amazon System Manager, which I'll talk about in just a little bit. The Ubuntu images on EC2 have as a kernel that has been specifically optimized for EC2. It's been optimized for boot speed and configured with the essential drivers that you need. That may not seem like much, but there's actually a tremendous amount of time and effort that's gone in by the Ubuntu kernel developers in optimizing this experience on Amazon EC2. Now, I want to take a moment here while we're talking about EC2 and talk about Ubuntu Pro. Ubuntu Pro is Canonical's premium image, and that is available for launching on Amazon EC2. It is the same Ubuntu image that you're running for free with some extra capabilities that are layered on top of that. Now, this is not a commercial for Ubuntu Pro. I'll leave that to Canonical, but there are some really cool things here that you want to know about, and I'd be remiss if I didn't mention them. For example, kernel live patch. You've definitely seen CVE's high profile exploits when they're announced. Canonical does a great job of having kernel updates available soon after those announcements, and those updates are available immediately for EC2 instances. New images are available shortly thereafter, typically within a few hours to under 24 hours, so that the new images that you launch using the SSM public parameters to find the latest image, those already contain a fix. But if you update your kernel on a deployed instance, that's still going to involve a reboot, and that may not be the most convenient thing to do in the middle of a business day. So with Live Patch, you can get the patch for that CVE applied directly to your running kernel automatically, and that will protect your instances until your next scheduled maintenance window when you have the opportunity to reboot. You also want to know about extended security maintenance, or ESM. ESM extends the security support window for Ubuntu LTS releases. By default, those updates are provided for 5 years for free, and there's no cost to you to get 5 years worth of support on those images. But if you need more than that, if you have a large fleet of instances or instances that you can't upgrade readily, you can extend that window for up to 10 years with security updates with ESM. Now, I can't be there to see a show of hands, but I'd be curious if anyone has ever had to run a workload beyond that 5 year period. I am aware of 1604 and even 1404 workloads that are still out there in the wild. In addition to the extended period of time, there's another aspect of ESM, and that is the expanded coverage of Canonical's support to community supported packages in the Universe repository. If you are familiar with the repositories, you know security updates for packages in main that are central to the OS. Those are provided by Canonical. You may be using packages from Universe since contains so many packages. You may be using those in your application, and you need to make sure that those are patched as well, both for the security of your workload and possibly for compliance reasons. So you can check the box that says that yes, we're supported. ESM is you can provide that for you and expand the range of packages that are protected as well as extending that coverage. On the subject of compliance, if you have workloads that require certification for FIPS or another number of other certifications for FedRAMP compliance, HIPAA, some of the others, those are available with Ubuntu Pro. Ubuntu Pro offers a FIPS certified kernel as well as FIPS certified cryptographic modules for OpenSSL and Strong SWN and others. So PubSec and enterprise workloads are very interested in those certifications. Anybody with production workloads should take a look at ESM and LivePatch. For the cost of those, pennies compared to what some of the other commercial providers charge, it really is a great value for your production workloads. Now, Ubuntu Pro isn't unique to AWS. It's available on all the major providers, but we're very proud to have that. So with 1804 coming up at the end of its 5-year cycle in April, if you're running Bionic Beaver workloads, you're going to be looking at that upgrade process. I would love to tell you that the process is seamless and painless on AWS, and you'll be able to implement it easily. I'd love to tell you that. The reality is that there's going to be some extra work involved as it stands today with obtaining a UA token from Canonical and getting that deployed out on all of your instances. What I can tell you today is we are very aware of the pain point, and that has not gone unnoticed. And be watching that for improvements when we can get that addressed. Now, in addition to EC2, we have Amazon Lightsail. That is our VPS-like offering. There's none of the advanced features of EC2. You may be able to deploy one instance or a handful of instances for your application at a reduced cost. There is support in Lightsail for Bionic and Focal. Jammy is not yet listed in the console. So those are options for deploying servers. What I want to do now is tell you about a brand new service that we just launched at the end of September, or a brand new offering on that service. That is Ubuntu on Amazon Workspaces. This is Ubuntu Desktop in the cloud. This is not the same thing as just installing apt-get install Ubuntu Desktop on EC2. This is an optimized VDI managed desktop. And I am excited about this for a number of reasons. During COVID lockdowns, we saw the challenge of supporting teams that are working from home, technical support for remote users, and onboarding remote users. It was very painful for companies that had to deal with that. With Ubuntu Desktop on Amazon Workspaces, you can provision new workspaces, new desktops for new users and new employees, new contractors in a matter of minutes. That can even be automated. And if you have in your organization, you're running another desktop, and maybe employees, developers are running virtual machines so that they can get the advantage of Ubuntu Desktop on top of those other instances. This will allow you to roll out a managed, consistent desktop experience across your teams that they can use alongside on top of their existing desktop OS. And from a security standpoint, all your files are securely stored on cloud-based volumes within the security perimeter of your AWS account. Application assets like source code and design documents are not stored locally on the user's laptop. There's no risk of those being lost if a laptop is lost or stolen. It's ideal for remote users. It's ideal for traveling users, users that are on the road a lot, and it's ideal for bring your own device scenarios, where users can just bring their own environment, run the Workspaces client, and have access to their managed desktop on top of that. Best of all, the desktop experience that you get with Workspaces is Ubuntu Pro. So it benefits from those features that we were talking about earlier. That is included. This was just launched the end of September. It's very new. Currently, only Ubuntu 22.04 is supported, and GPU-focused G4DN bundles are not yet available. They will be available in the coming weeks. One caveat using Workspaces, it does require Active Directory integration. So you could use Simple AD, AWS Managed AD, or your own Active Directory. This may not be ideal for individual users who are just looking to spin up a desktop. I do apologize if I'm talking quickly. It's probably going to get worse because I have a lot here that I want to introduce you to and very limited time. Moving on to containers. Amazon has two managed container services, Amazon ECS and Amazon EKS. I don't really have time to compare and contrast them in too much detail. Some of you are undoubtedly familiar with Kubernetes. I won't spend a great deal of time on that. The takeaway here is whichever one you choose for your workload, you can use official Ubuntu images as the container image. Ubuntu images for ECS and EKS are produced by Canonical alongside the official EC2 images and are kept up to date with the latest security patches and bug fixes. You can find them in the AWS Container Marketplace. Now, it doesn't end there, because a while back, AWS released ECS Anywhere, which allows you to use ECS on premises in your own systems, your own data center. You can register your systems to ECS using the AWS Systems Manager agent, which we'll discuss in a few minutes. And then you can manage your on-premises container workloads using ECS. And we also have EKS Anywhere, which allows you to deploy Amazon's Kubernetes on-premises into your environment. If the Anywhere projects interest you, just note that there's more work involved in deploying those on-prem than deploying solely on AWS. It's not a fully managed experience. While I'm on this slide, I do want to point out the supported operating systems at the bottom. You notice there aren't that many currently listed, but Ubuntu is included. And this is something you're going to see as you watch new services or integrations on AWS. Ubuntu is typically among the first Linux distributions supported at launch right next to Amazon Linux. And that is driven by customers telling us that that is what they want. So I've included a few resources here to help you get started with EKS Anywhere and ECS Anywhere. They are open source. The installation isn't difficult as far as Kubernetes installations are concerned. One last note, if you want to get up and running with a containerized application on Ubuntu quickly, look into the Fargate deployment options on ECS and EKS. This model is completely serverless from the user perspective, and that allows you to focus on your application rather than managing the cluster itself. Okay, before we get to talk about a few of the developer tools, I want to spend some time talking about the area of administration because I think that this is widely applicable. If you're using resources that you have to manage yourself, like an EC2 instance, you're going to need to keep it up to date. You have basic tools like apt, you have products like Landscape from Canonical and some third-party products. I want to touch on AWS Systems Manager, specifically a couple of features of Systems Manager or SSM that are widely used on Ubuntu instances. To use SSM or any service that integrates with it by SSM, you're going to need the SSM agent installed. Now, the good news is that all Ubuntu images on AWS include the SSM snap already installed by default. However, because this may be news to you, the SSM agent is not running by default. It has to be configured before it can run. You'll need to create an IAM service role for EC2 and attach the Amazon SSM Manage Instance core policy to that role, and then attach that role to your EC2 instance, and then the SSM agent will start. And there's some extra steps here that the reason for that will become clear momentarily. That is how you enable the SSM agent on your Ubuntu instance. And you could do that programmatically too, as well as as part of your CloudFormation scripts or other deployment tools that you use. Okay, now that you've got the SSM agent up and running on your hypothetical EC2 instance, we can talk about the SSM Session Manager. Session Manager provides a shell into your instance without the need for SSH, without the need to manage keys or open ports. Because it operates directly through the AWS console, you're not going to connect to port 22 over the network. It's basically a one-click web browser experience, or you can use the AWS CLI. Now, it's very useful for recovering an instance when the instance malfunctions, but it's still running. But you're not able to access it over SSH. There's no need to even have the SSH key for the instance. Now, if that sounds dangerous to you, that's one of the reasons why SSM agent isn't running by default on your instances. On the other hand, if you've never used it before and you suddenly discover that you need it, that is not the time to be trying to log into the instance to install the SSM agent. So that's why it's pre-cached on the image, and you can simply apply the IAM role in most cases. The SSM agent is going to come up after a few minutes without even the need to reboot. A session manager supports IAM access control, and you can limit who has access. You're not handing over the keys to the kingdom to your entire team. Activity can be logged. And here's a screenshot of the Systems Manager console. You can see under Connect, you have the option to start a new terminal session. One thing I forgot to point out is you can even set time limits on the accessibility over the session. So if you need to give access to someone temporarily using Session Manager, that's supported as well. So in the screenshot, look down a little bit below Start a Terminal Session to patch nodes. And we're going to talk about that next. The SSM Patch Manager automates the process of patching managed nodes with security patches and other types of updates. You can scan for the needed patches manually or on a schedule. You can patch instances in groups by using tags. It supports defined maintenance windows for predefined times where it's okay to patch. Patch Manager supports rate control so that you can define a maximum portion of your environment that's being patched at any one time. And you can install packages from the repositories. You can make changes directly with run command in your automation document. You can have SSM Patch Manager generate reports on the patches that are installed and upload those directly to S3. Now, the source of truth for the packages that are installed, or that need to be installed, is polling the repositories themselves. So the SSM agent will go out and check the repositories and see if there are packages updates that are available, and then it will notify you. Okay, moving on quickly to developer tools. Again, I apologize for talking so quickly. I probably tried to cram a little bit too much into this presentation, but there are a vast number of things that we're not even going to get a chance to talk about today. So now that we've reviewed the services on which you could deploy Ubuntu and some of the administration tools, let's change direction a bit and talk about some of the software developer focused services and how they integrate with Ubuntu. I'll start briefly by briefly talking about AWS CloudFormation. This is a good place to start for infrastructure as code. To really see the scalability benefits of cloud, where you're scaling your environment up and down to meet demand, you need the ability to provision new resources programmatically. AWS CloudFormation is a service that lets you model your AWS resources as templates that you can deploy over and over again. And you could deploy a single resource or an entire environment with a single CloudFormation template. Here is an example of a CloudFormation template deploying an Ubuntu instance. It's only a portion of the template for simplicity. You could use YAML or JSON to format the template. I'm using YAML here. I need to stop here and point out something about SSM public parameters. We touched on AWS Systems Manager. Public parameters, we mentioned when we were talking about compute. You could use the public parameters to store your own data. I'm not going to talk about that here, but I want to show you that Canonical publishes the latest Ubuntu image ID as a public parameter under the AWS Service Canonical namespace. And you can reference that parameter to always get the AMI ID of the latest Ubuntu image in any region. You can do that from your scripts using the CLI. You can also do that here in CloudFormation without the need to update your CloudFormation every time there's a new image or a different region. I do apologize for the way the YAML wrapped here, but you get the idea. Okay, moving on to code build, AWS code build. It's a fully managed build service in the cloud. Code build compiles your source code, runs your unit tests, produces artifacts that are ready to deploy. It eliminates the need to build and maintain your own build servers. It scales automatically to meet your build needs. You do pay only for the build minutes that you use. It provides pre-configured build environments for the most popular programming languages. And build environment represents a combination of operating system, programming language, runtime, and tools that code build uses to run a build. Code build supports 2204, 2004, and 1804 runtimes, as well as AL2 and Windows. You can use code build to build locally on your own systems, not just on AWS. I could do an entire demo on code build showing you all the capabilities, but we'll have to save that for later time. I wanted to show you here that it does support Ubuntu directly and officially. Moving on, AWS Code Deploy. AWS Code Deploy is a deployment service that automates application deployments to Amazon EC2 instances, on-premise instances, or Amazon ECS. For EC2, you install the Code Deploy agent on your system, and Code Deploy handles the deployment for you, a wide range of customization options for your deployment. Code Deploy can deploy application content stored in S3 buckets. It can use GitHub repositories or Bitbucket repositories. S3 buckets primarily used for integrating with AWS Code Build. It integrates with a lot of popular CI/CD systems, easy for me to say. You could do rolling deployments throughout an auto scaling group, pulling an instance out, redeploying and putting it back in. You could do full blue-green deployments where you stand up an entire copy of your environment. It's one of the benefits of deploying to a scalable environment like AWS. You can automatically cut over to the new environment or manually cut over to the new environment and then bring the old instances down. Code Deploy has been tested on Ubuntu 1804, 1604, and 1404. That unfortunately is pulled directly from the AWS website. I want to pause here and mention that AWS does not always align with the Ubuntu release schedule or deprecation schedule as closely as we should. You're going to find places where Jammy support hasn't been added yet, or you're going to see older releases that shouldn't be there outside of ESM. What I can tell you at this point is I'm working on that, and it's going to do better. We're working on that, and I'm working on that. Okay, back to Code Deploy. There's a lot of features I don't have time to show you today. I could do an entire demo on Code Deploy, but that's not what we're here for. Besides, undoubtedly, some of you here are more experienced with automated deployments than I am anyway, so go have a look. Okay, I am nearly out of time, but I wanted to show you one more place where Ubuntu shows up very prominently in AWS, and it's a very hot topic overall. That is machine learning, which is a use case that Ubuntu is particularly well suited for. If anyone's doing anything with machine learning, you know there's a large number of open source frameworks and tools for that. Some of them are very good. Some of them are very widely used in the industry. And if you've had to install them, you've seen that they could be a bit awkward to install and make sure all the dependencies are met. The deep learning AMI is an AMI in the AWS marketplace that's built from an Ubuntu image. And these are provided by AWS. They're not canonical. They are built on the official Ubuntu images. They include a number of these open source tools that have been installed and configured for you already. I've listed some of the popular machine learning frameworks that come pre-installed along with the image, their dependencies have all been addressed as well. The image includes NVIDIA drivers, so you could take advantage of GPU dense instances like the P3. The Habana images are configured to take advantage of the Habana Gaudi accelerators on the DL1 instances. And that is all I have time for today. I know that was a bit rushed, and I didn't cover any of the things that we talked about in much detail. My objective today was not to teach you about AWS as much as to show you the ways in which Ubuntu is being used there and how much the Ubuntu maintainers in AWS have accomplished so far in integration and support. Some of these efforts, like workspaces, are just getting off the ground, and we have a lot to look forward to in the future. Um, I'm not there to take any questions today, but if you have any and you want to get a hold of me, my contact information is on the last slide. Thanks very much for taking time to be here today and listen to me speak quickly. Have a good one.